running on a Solaris or an AIX machine, then, I mean, we are not reinventing the wheel. All you have to do is generate the right Metasploit's payload and send it onto the server. So this should work in all conditions. Right. Next, I wanted to talk about a class of vulnerability which I feel is not very much discussed, and that is non-interactive second-order injections. So what I mean by non-interactive second-order injection is this. So if you imagine an e-commerce website or any website which allows a new user registration functionality. So imagine an unauthenticated attacker attacking a functionality such as this. So he tries to inject something like evil functions into some arbitrary random fields, but the query which gets executed on the server side is actually secure. So as you can see, it is using bind parameters. So that particular field is not vulnerable. So all his attempts are going to be in vain because this is a safe code. So whatever he injects gets stored into a table, and because that particular code is not vulnerable. Now, what happens if an admin user then goes and moderates this particular user, which have been created with some crafted functionality, crafted strings? The code which gets executed when the admin user approves this functionality is vulnerable to SQL injection in this case. So whatever the malicious user has injected got stored into a row of the table. That particular value of the row of the table is then being treated as a string and then passed on as an argument to var2 over here. So the functionality which admin user executes is vulnerable to SQL injection. This functionality is never seen by the attacker, and the admin user is trusted. So for an admin screen, this is what is possibly going to happen in the admin session. But the bottom line is that the admin user is trusted. So even if the malicious user injected something which will dump the database version or any sensitive data, that would be dumped on the admin user screen and not on the attacker screen. So this is what I call as a non-interactive second-order injection. There is definitely a problem. There is definitely a SQL injection, but it does not occur within the attacker session. So example, attacker places an order via an e-commerce application. Admin logs in and approves the order. The admin session is vulnerable to SQL injection. And although the attacker does not see it or does not have any method to interact with it, the attacker's input does get passed onto the vulnerable SQL calls. Another example of this vulnerability could be that so the attacker's input, which is stored in a row of a particular table, gets acted upon by a trigger. Now that trigger can be called as a result of a batch job which runs every night. So what I'm saying is that the attacker has no way to identify this problem, and the injection does take input from the malicious user. Right. Other examples of this vulnerability is if you find a cross-site request forgery in the admin section. So, for example, consider an admin session's screen, which is vulnerable to cross-site request forgery, and it either allows execution of arbitrary SQL as a feature, or because admin screen is vulnerable to SQL injection. In either case, whatever attack payload you inject, that will be executed only once. So, how can we make all these scenarios of non-interactive SQL injections interactive? Can we do something to regain control of the SQL injection, which we don't actually see out there? So there is a concept of one-click ownage. The original concept was from Fayó. The idea is simple. We run MSF payload to create a binary, and so we need to make sure that we upload this binary and execute this binary onto the database server. So we convert that binary into hex. If you convert the binary into hex, the size will be double. So we use some reduction functions. We write a VB script that can process this hex string and generate a valid binary file. So the idea is in one single request, we can get a reverse Metasploit connection back to us. So shell.exe is generated by Metasploit, Metasploit's MSF payload. Then shell.exe is is compressed and hex encoded with decryptor stub attached. So we create this VB script. When this VB script will be run, it will create the Metasploit's executable on the target server, and then we run the Metasploit's executable. So this VB script can be deployed using things like XP_CMD shell on the MS SQL server. Let's just, okay, so this is how it will look like. One long massive string, which will do the job for you. I mean, usually when we talk about getting an interactive access, you will either upload via TFTP or you will upload bit by bit using debug.exe. So this solves that problem. And most importantly, you can just blindly use that as a fuzz string and fuzz into every field and get control of SQL injections, which don't really happen in your session. So this was the original one-click ownage from Fayó, which worked for MS SQL. So we did the same for Oracle. So if you have Java IO permissions, then you can, this is the attack string, which you can use for Oracle. Obviously, depending on what public IP you want to throw reverse connection on, this hex will change. Next is, so when we wanted to do this with DBA privileges, then things didn't quite work. So the obvious question was, again, we can grant, as a DBA user, we can grant ourselves Java IO permissions and then execute the previous step. We can do that, but the problem is if you grant yourself Java IO permissions as DBA, then those permissions are not available in the same session. So technically, you have to log out and log back in, and then you will have those permissions which you have granted. So technically speaking, it won't quite be one-click ownage. It will require more than 1 or 2, 3 clicks. You can do something like grant Java sys permissions to the public role, and then the permissions will be available in the same session. But if you are doing pen testing consultancy like I do, then granting something to public and the client will not be very happy. So, okay, if you remember with DBA permissions, we were executing code by calling a DBMS scheduler. Now, the problem was so when we ran DBMS scheduler, can we not pass the entire thing as an argument to DBMS scheduler? Well, it would have made my life very easy had that worked, but it didn't work. That's because DBMS schedulers create program procedure, which we are calling. It can only take up to 1,000 characters as input. So that did not work. Okay, I think sorry, the slides are the other way around. So what finally worked is we created a directory. Within the directory, we create a procedure to write files on the system using by calling utl_file. We execute this procedure to write the VB script which we want to write. We execute the VB script to create Metasploit's Metasploit's executable on the target Oracle database, and then we run this executable all in one request, and that's how the request looks like. So we are doing quite a few things in one single request. Right, so let's see a demo of one-click ownage. So there is already a tool, WebRaider. We've just wrote a few plugins for WebRaider, which will let you do stuff in Oracle. So we again go back to our blind SQL injection. Obviously, I mean, in this particular example, we are using this technique for interactive injections, for exploiting interactive SQL injections. But the idea behind this is that you use this for non-interactive ones as well, which you don't really see. So what you do is you choose your public IP address on which you want to throw the reverse connection. You choose your attack. What attack you want to carry out. You want to carry out a SQL injection in Oracle or with DBA permissions or MS SQL, whatever. Once you choose, once you save that, then, okay, let me just pause this for a minute. Okay, so the idea behind this is that this will essentially give you the payload which you want to be injecting for non-interactive SQL injections. So it will give you a payload which is URL encoded. So if you are carrying out a SQL if you are authenticated to the website and you have, I don't know, some CSRF token protection, so we didn't want to have cookies and everything added into our tool. So you can basically just take this string and inject into the relevant get or post parameter and carry out the job. So it will give you a string which is URL encoded to carry out injection from web applications, or it will give you the other one for interactive like SQL plus connections. Okay, and then if it is a simple GET request, you can just click on the start button, and this will give you reverse shell, Metasploit's Meterpreter shell in one click. There you go. So Meterpreter session open. Okay. Ooh. Okay, so moving on, using this particular function, create master process, you can execute DML and DDL statements. So like you can do grant DBA to any particular user. If you can execute DDL or DML statements, then obviously you can write SQL injection worms. SQL injection worms rose to the scene almost 2 years ago. All they do was change the web application's front end to inject malicious JavaScripts within the iframe of the front end and then distribute browser exploits. Same worms can be written for Oracle-based applications. For example, if SQL injection worm in MS SQL looks like this, then you can write a corresponding SQL injection worm in Oracle. So Oracle applications can be equally vulnerable. It's just that they have not been exploited in the wild. Right, so moving on. So is there anything that we could do to protect sensitive data in the database? I mean, you can defend your applications against SQL injection, but what if you want to have some defense in depth mechanism to say that even there is a SQL injection, the data which the attacker gets should be pointless. So that's where I think compliance comes into picture. So PCI compliance mandates that the card data, the PAN, must be stored encrypted. The distribution of keys used for encryption, decryption should be controlled and regulated. So what happens when an attacker finds a SQL injection vulnerability in such a website which follows all this compliance? Does that mean that the card data which the attacker gets is all encrypted, so it will be pointless for the attacker to have this data if obviously he can't get the keys for decryption? So for example, here is a sample from a particular credit card table. As you can see, the card data is all encrypted. So even if you were to find a SQL injection, the data which you have without the keys will be pretty much useless. Right, so what I found was, what happens in this regulation, does it talk about where the encryption occurs? Does it occur, or should it occur at the database level, or should it occur at the application level? So what if the encryption occurs at the database layer? So in this particular case, there is an application server, which is different from a database server. So you have a 3-tier architecture. And so for storing credit card information, we are doing an insert statement. And while inserting, we are calling a built-in Oracle function, which is DBMS obfuscation toolkit .triple-encryption. And this des3 encrypt function takes the card number as one argument and takes the encryption key as a second argument. Okay, so this is actually quite interesting. So this makes me think that what is more important here, the data or the query? Although the data which is stored in the database would be encrypted using this mechanism, but the query which will be executed on the database server will actually have the clear text PAN and the clear text string in it. So at any point in time, whenever that query executes on the server, if I can get a log of that SQL query, then I'm pretty much done. If I can obtain that query, then I don't really care about the data, because that query will have the clear text PAN, and more importantly, it will have the clear text string. So I am not interested in data, I'm interested in the query. So the SQL queries executed on the database server, they can be forensically obtained. $SQL is one table in Oracle which lists statistics on shared SQL area. This table typically stores last 500 queries. So if you repeatedly keep querying this table, you will find out all queries